Is it visible, the screen? So for today's format is first I'll go through introduction in 5-10 minutes, and then we have 5 speakers today who would be talking about Kubernetes and around development and different products which help Kubernetes. And then before moving on to the topics, we will do a small cake cutting celebration. Okay, a small cake cutting celebration, and then we'll start our sessions today. So K8SUG Singapore 30th meetup. We have 14,800 people as a member across the globe, 6,400 LinkedIn followers, and 8,600 plus LinkedIn group members. In the past 10 years, what Kubernetes has, it has 88,000 contribution and 8K contributing companies, made 314K code commits, 263,000 pull request, and 3 million plus contribution. Our mission is very clear. We are very passionate about Kubernetes technology, and we want to accelerate the Kubernetes adoption. And with the help of the community, we want to spread the word around Kubernetes and also help people to grow, learn Kubernetes, and get trained and certified into Kubernetes. Somewhere around a year back, we started the first Kubernetes in Singapore. And in 1.5 years, now if you see, we have a global footprint. We started in Canada, then Australia, and then we started in UK. And good news in ASEAN region, next month we are starting in Philippines. Thank you. So today we have 5 speakers with us, and the first we have Wayne from AWS, who would be talking about best practice in building multi-architecture container images. Then we have Mark Mooney from KAEPE Deployment, who would be talking from code to cluster, implementing CI/CD and Kubernetes with KAEPE. We have Dinesh Weerakkody from WSO2. He would be talking about K8s Gateway API, exploring the capabilities of new Gateway API using WSO2 APK. Then we have Arvind Kurapati from Catalogic Software, talking about K8s application mobility, how to protect and migrate your stateful application data at scale. And finally, we have our own Daniele Polencic from Learn K8s. Whoever know about Kubernetes, they know Learn K8s, and we are honored to have him today with us, who would be sharing with us tips and tricks to right-size your Kubernetes cluster for efficiency and cost saving. Round of applause to Daniel. So our main sponsors today is KodeKloud, AWS. For KodeKloud is our long-term sponsor, and you know every month we give away KodeKloud subscription to first 3 winner of the quiz. And AWS, thank you very much, AWS, for sponsoring us the venue. And we are already booked the AWS venue up till December. So thank you very much, AWS, for supporting the community. And for today event sponsor, we have Learn K8s, Catalogic, WSO2, CNCF Cloud Native Community Group, CNCF Singapore, and KAEPE Deployment. Meet our team, Yongkang, he is CNCF Cube astronaut and founder. Fazir, my colleague, one of the founding member, and myself, Ritesh, founding member of K8SUG Singapore. And we have a very dynamic team of volunteers and organizers: Rama, Sivaya, Fatima, Shivangi, Jinesh, and recently, we also have Kalyan, Anuj. So I think we have to update this. We have couple of more people. Alok and Anuj is also there, who are helping us with K8SUG Singapore. These are the upcoming events which we have in UK, Australia, and Melbourne, Australia, Sydney, Canada, Singapore, and Philippines. As I said, we are expanding our footprints in ASEAN region. The next region would be Philippines. That would be happening next month in August. So anybody who would want to join us as a speaker, they can scan the QR code. If you want to join us as a volunteers, join the scan the QR code, update. And if you want to be a sponsor, most welcome. Scan the QR code and update the details. Now with that, I would like to call our sponsors, Wayne, Mark, Dinesh, Arvind, and Daniel on the stage for cake cutting. We'll do a small cake cutting, and everybody else can also join us. So we are going to sing the same birthday song, but instead of to you, we will say happy birthday Kubernetes. All right? 1, 2, 3, start. Happy birthday to you. Happy birthday, Kubernetes. Happy birthday to Kubernetes. Happy 10th birthday, Kubernetes. You guys can have it one by yourself. All right. Okay, so Rama, take the cake, you cut and keep it. Whoever wants the cake, it would be outside. You can take it and come back and join us. With that further ado, let's start. I would like to call Wayne to talk about best practice building multi-architecture container images. Give a round of applause to Wayne.
Yeah. All right, can start. So good evening, everyone. I'm Wayne. I'm actually from AWS. So welcome everyone to AWS today. So I'm actually the principal EC2 Graviton Specialist Solution Architect. So I specialize in Graviton. If you have not heard of Graviton before, it's basically our ARM64 based processor, right? So that will be the topic that I will share for today, right? So I will be sharing about how you can leverage ARM instances to lower your cost. And most importantly, since we are on containers and Kubernetes, what are the best practices around enabling your containers to be able to run on ARM? So before I start, I would like to understand the amount of knowledge that's in the room. So who has actually used ARM64 servers in the data center? Please raise your hand. Okay, some of you are you all using Graviton or something else? Okay. Anyone using non-Graviton in a data center? Okay, there's one. That's good. Okay, great. So some of you do know it already, but most haven't. So I will level set everyone with the basic knowledge, all right? Okay, so this will be the agenda. So basically, we are going to go through how you can reduce your infrastructure costs by up to 40% with our Graviton-based instances. And then how do you build your multi-architecture container images so that you can run on both x86 as well as Graviton. And then I will deep dive into some of the best practices around it, all right? Okay, so if you go out there and use one of the open source project today, right? Whether you are downloading from the Docker Hub or you are building your own container image with some open source software, it is very likely that it already support ARM today, right? So 80% of the graduated CNCDev projects are natively supporting ARM. So some of the popular ones like Flux, Helm, Prometheus, OpenTelemetry, FluentD, Envoy, etcd, Istio are all supporting ARM today. Okay, and This is very common, and the reason why they are doing so is that it's actually helping them to reduce costs, right? And Datadog has actually done this analysis. Not sure whether you have seen this report on the Datadog website, but this was what they came up with earlier this year. So they went to analyze all their AWS users that is running Datadog. And what they found is that for those customers who are using Graviton ARM-based instances, 1 year earlier, they were using, it comprises of 9% of their EC2. And a year later, it actually went up to 18%. So that's 100% growth, right? And it's quite a lot. So in time to come, many analyses actually predict that it will probably occupy half of the data center in time to come. So we have taken the leadership to create our Graviton ARM64 based processor. We acquired a company called Annapurna Labs in the early days. We were collaborating with them to create our Nitro hypervisor, and we create the Graviton processors, and we manufacture it ourselves. But many other companies are following our leadership, right? So whether or not it's a cloud from Alibaba or Huawei or even Microsoft and Google, they are creating their own ARM-based processors as well. And if you own your own hardware, you can even buy an ARM-based server from Ampere Ultra. Okay, so you can buy a server and run it in your data center. And Ampere Ultra is also the servers that Microsoft and Google are using for their ARM-based processors at this point in time. So a little bit about the business benefits, right, of Graviton processors. So as you can see, it has been around for quite some time. In 2018, we came out with the first generation, but at the moment, we are already in our 4th generation. So with Graviton 2, you can get up to 40% better price performance. So many have asked me, how do I get the 40%? Now, the 40% here, we are actually comparing it to the Intel-based instances that's on AWS. So if you take a look at the on-demand price of our Graviton-based instances versus the Intel instances, you'll see that it's 20% cheaper. And also, the other 20% comes from the performance improvement. So you can actually run less pods, less EC2 servers to serve the same amount of requests. And they are also more energy efficient as well. So with Graviton 3, it's 60% more energy efficient than the comparable x86 instances. And that's how we can lower the cost, right? So by using less electricity in the data center, we are able to pass back the cost savings back to customers like yourself. So we just GA Graviton 4 last week, right? And they actually provide 30% better performance and also 50% more cost than the Graviton 3. So with every generation, we are trying to bring about at least 25% more performance improvement. So for those of you who are not familiar with the Graviton instance naming convention, right? So you will notice that they come with a suffix of G, okay? So we have the CMR family like the C6G, C7G. C6G will be the Graviton 2, Graviton 3 will be C7G. And we also have Graviton 3E that comes with at a higher frequency and Graviton 4 as well. So for those of you here who wants to actually try this out after today, right? The lowest cost Graviton instance at the moment is our burstable T4G instance that's based on Graviton 2. So if you run the T4G on spot instances in AWS, that's the lowest cost ARM processor that you can get. So you can use it for testing before running the production workload on the CMR instances. And for those of you who needs GPU capacity, you can also look for the G5G instance, right? So they are comparable to the G4DN. So it comes with an NVIDIA T4G GPU, okay? And right at the moment, they are also great in terms of the spot pricing as well. So how does that performance impact come about, right? So if I actually do a benchmarking in a virtual machine or EC2, this will be the graph that you will see. So I'm comparing the CPU utilization versus the application latency. And you'll see that for x86 as well as Graviton instance, the latency will more or less remain flat when you drive up the CPU load. But for x86, it can only maintain that latency up to a certain point, which is about the 50 to 60% mark. This is because the hyper-threading starts to kick in, right? So your 2 vCPU in the x86 is equivalent to just one physical core. So they have to share the physical core. So that is also why for many of you who run HPA, horizontal port autoscaler, you will set the CPU threshold at about 50 to 60%. And beyond that threshold, you start to scale out to have more ports. But however, for Graviton instance, every vCPU is one physical core, right? So for the same amount of vCPU, you are actually getting more physical cores. And that's why you can increase the CPU utilization and your latency will not suffer. So if you make use of that additional capacity that's inside your EC2, you can actually get the shaded area that you see over there, which actually represents the unlocked capacity. So if you are running 5 ports on x86 instances, when you switch over to Graviton instance, you might end up running 4 ports, right? So that's the 20% performance improvement that I'm talking about. Okay. So next, I will dive into some of the best practices that I see when you leveraging ARM instances. One important point is that the more recent your software is, the better the performance on ARM. Why is that so? Taking the example of Java 8, right? Java 8 is very old already and is already out of support, but many customers are still using it. But you will find that Java 8 comes before the ARM64 standard. So that's why the compiler doesn't optimize for ARM64. But however, if you upgrade your Java to Java 11 or even 17, you will get much better performance. And the software does not include just the programming language, but it also applies to the libraries that you are using. It also applies to the operating system that you are using. So if you are still on Amazon Linux 2, you will get better performance once you migrate on to Amazon Linux 2023 on Graviton instances as well. So now that you know the benefits of ARM-based instances, how do you leverage it for your container workload? One important thing that you have to build is what we call a multi-architecture manifest list, right? So in fact, today, you'll probably be building just the x86 manifest file, as you can see over here. So when you do a Docker build on your laptop, you will be building the x86 base manifest file. But however, if you are running an Apple Silicon laptop, like the M1, M2, M3, and they have just announced M4 as well, you will be, when you run the Docker build on the Apple Silicon laptop, you'll be building an ARM-based instance, right? I don't know whether you have noticed that. So that has a lot of synergy with the Graviton-based instances. So if you build on your Apple laptop today, you can bring that image and run it on Graviton servers. So the criteria for you to run multi-architecture is that you should be creating a manifest list, which is none other than a JSON file that actually reference the x86 image as well as the ARM image. Okay, so many of the community projects on Docker Hub are already multi-architecture in nature. So if you pull down Nginx today on your Apple laptop, you'll be pulling down the ARM base, right? So it will actually reference your host and pull down the corresponding CPU architecture image to use. So it becomes transparent to you. So you don't have to, at any point in time, specify and say, I want to use the x86 image, or I want to use the ARM image. It will still be the single image name with the single image tag that you are leveraging today, right? So that decision is made by the container runtime. So how do you actually create this manifest list? You can actually run a Docker manifest create, followed by your ARM Docker image name and the x86 Docker image name. So it's pretty straightforward. Okay. So how do you build that into your pipeline? So whether or not your pipeline is running on GitHub Actions, GitLab, CI, or Jenkins, right? You will be able to create your pipeline such that it creates both the ARM as well as the x86 image and check into the Docker registry, right? So our ECR and many of the registries out there already support multi-architecture Docker images. So you'll be able to push your multi-architecture image into the registry. And the manifest needs to be created and pushed into the registry as well, right? So you end up with 3 artifacts, right? 2 images and a manifest list, which is a JSON file. So there will be 3 artifacts that's sitting in your registry, and that actually makes up the multi-architecture image. And for those of you who are more advanced, you could be running your pipeline in Kubernetes itself. So you could be running Jenkins pod and creating Docker builds over there, right? So over here, I have an example whereby I'm actually running Kaneko as a container tool to create the container image. So the Kaneko build happens on an x86 instance, and it also runs on the Graviton instance as well to create the Docker image file on ARM. And then I will use Podman to actually do the creation of the manifest list. And there are many tools out there, right? So whether or not you use Kaneko or Builda, which is supported by Red Hat, or Podman, or the Docker build kit, right? You can actually do your container build, right, on your Kubernetes cluster. So some of you at this point in time, you might think, oh, I have to adjust the pipeline, which could be quite troublesome, right? If I just want to give it a try. So if you want an easier tool to create multi-architecture image, then Docker has actually released a tool called Docker Build X. So you can actually install this tool into your laptop, whether or not it's an ARM laptop or x86 laptop. And with one single command, you can actually create the multi-architecture Docker image. Why is it that it's able to create the ARM image on an x86 laptop? It actually makes use of the QEMU emulator, right? So it's converting all that x86 machine instruction set to the ARM instruction set. So it does that for you. So it becomes very convenient. But however, bear in mind that the trade-off is performance. Okay. So I have some customers who use this in their pipeline, and they realize that their Docker build went up for a couple of minutes to 40 minutes, right? So it can take much more time to run this tool. So at this point in time, there may be some question in your mind. So you could be thinking, oh, do I need to change my programming language and code, right? No, you don't have to change any of the code, right? And how about the Docker file? You don't have to change your Docker file as well, because many of the instructions in the Docker file remain the same, right? But in case some of your executables and binaries are different in ARM as to x86, then what you can do is that you can actually leverage the variable target architecture that's supplied by the Docker itself. So you inject this variable depending on what platform is actually building on. And you can make use of that variable to do condition statements to say, if it's on x86, I will use this binary. If it's on ARM, I will use another binary. So you can do things like that. So that you, any point in time, you only maintain one Docker file, right? So you don't have to maintain two separate Docker files for x86 build as well as ARM build. Okay. But of course, I recognize that some of you could be running cloud-based, cloud-hosted ARM runners, right? So you could be using tools like the GitHub Actions, Bitbucket pipelines, or even the new Docker Build Cloud, right? So these tools actually maintain those servers on your behalf. So it's serverless in nature and very convenient to use. And most of these pipeline tools already have ARM servers, right? The only one that doesn't have at the moment is the Bitbucket pipeline. But you can use a workaround, which is to use the self-hosted runner. So you can actually create it on a Graviton server and manage the server yourself. Okay. So now that we have gone through the build part, right? Next, how do I provision ARM servers, right? So you can see that for your Kubernetes cluster, it can actually comprise of both x86 node group as well as an ARM node group. So when you do a deployment of a multi-architecture project, right, that deployment, depending on the Kubernetes scheduler, it will go to the ARM node, or you will go to the x86 node, or you will go to both, depending on where is the spare capacity. But if you want to select one of the CPU architecture to deploy the pods on, you can still do that. For certain workloads, you can use Kubernetes constructs like node selector, node affinity, anti-affinity, taints and tolerations, right? To actually choose the CPU architecture that you want your workload to run on. And more recently, AWS has open source a tool which takes care of the EC2 provisioning as well. And many of you will be using the EKS with managed node group today, right? And we went back to the drawing board and see how we can reinvent the experience and bring about more innovation. So we came up with this tool called Carpenter. And what Carpenter will do is that it will provision the EC2 for you so that you don't have to maintain no groups anymore. There's no concept, no more no groups to maintain, no more auto-scaling group to maintain, right? So things become more simple. And there are other benefits such as right sizing of the workload, right? So it saves costs for you. And it also consolidates underutilized or empty nodes as well, right? So that also saves costs for you as well. So why do I want to introduce to you Carpenter, right? This is because it supports ARM quite well. So you can see that in the Carpenter configuration, with just this set of configuration, which is called a node pool, I am provisioning both x86 and ARM64 for CMR instance of instance generation that's greater than 5, right? And conversely, to do this set of configuration inside a cluster autoscaler, right? I have to create many node groups and many auto-scaling groups, which will be very cumbersome and hard to maintain, right? So if you want to try out Carpenter, this is the best time to do so, right? And you'll find that you'll get a good experience. So what are some of the release best practice? So when you actually have tested out Graviton and you want to roll out your deployment onto Graviton, you can actually combine the release with customize, right? So I believe some of you may be already using Kubernetes customize in your deployment. So you can create, customize helps in customizing the configuration. So you don't have to augment the original deployment file that's deploying on x86, right? So you can inject things like node selectors and create new configuration, or you can even adjust the resource allocation, like the number of pods, once you have performance improvement on Graviton server. Okay. And once you try to roll out onto production, right? Then there is you can do what we call a canary release to actually lower the risk, right, for you. So I'm not advocating that you convert your production workload 100% to Graviton instance overnight, right? But instead, try out a few of the Graviton servers first as part of your x86 fleet, right? And then if you're happy with the stability, the robustness, the performance of it, then increase the percentage that's on Graviton over time. Okay, so this is my last slide. As a call to action, we have some hands-on labs that's available on the internet, right? So you can look for it. We also have a migration guidance that's available on GitHub and it's open source. So you can contribute to the best practices there as well. And also try out Carpenter. And for those of you who would like to use this and want to have a private conversation, right? Here's my LinkedIn. Feel free to reach out for a meeting. All right. Cool. All right. So I think I've come to the end of my time slot. Are there any questions before I hand it over to the next speaker? Thank you.
All right, thank you very much. Thank you. Welcome back. And I hope you guys enjoyed the game. We are going to start with the second topic. And the second topic is connecting CI/CD and Kubernetes. And I would like to welcome Mark Mooney, product lead from K8s. Please give a round of applause to Mark.
Thank you. Yes, thank you. Good evening, everyone. Thanks for joining me this evening. Audible for everybody? Good, good. To start off, yes, I'm going to do a short session on K8s along the lines of implementing CI/CD. It's not a mistake there. We're going to be purely focused on the CD part of it as the things start to shift in the CI/CD world more towards GitOps and CD perspective. That's the area that we're focused on from that perspective. So as I say, it's not a mistake or a leftover, it's on purpose. Quickly, just about KAEPE. So KAEPE is a Kubernetes-based and Kubernetes-focused continuous deployment or continuous delivery tool. We're very much focused in a number of areas. Firstly, simplifying and automating Kubernetes where we can in and around deployments. Extending what can be done with obviously GitOps and the whole platform engineering as we move into those areas. And also looking at it from an enterprise perspective. How can we assist with the enterprise needs and requirements that come out that impact a lot of us as we're doing our daily work. A lot of our work that we do, there are policies, there are constraints that we have to be very aware of. So KAEPE specifically takes that in mind from that and make sure that we can try and cover as much as possible that. Also, KAEPE is an enterprise product. So out of the box, we do offer support straight with it, and all customers are treated the same in that aspect. The main areas that we talk about within KAEPE itself is from a concept of KAEPE Anywhere. So one of the big tenets is that we do look at multi-cloud, on-premise, hybrid, edge, and even getting into areas of secure clusters and so on. So we're very much focused on being able to have KAEPE slot in to your pipelines without any need for any changes that you may have to do. Just drop it straight into your pipelines. So whatever repos, whatever registries, whatever manifests, whether customized, Helm, straight YAML, and so on. So we're very much focused on being able to drop just in and then build from there. Build from there in areas of confident delivery, progressive delivery, making sure that we can also offering hosting options, whether that is a SaaS offering or on-premise offering, or self-hosted for your own infrastructure, and also getting into areas as we move forward of being able to manage serverless along with Kubernetes and automated prompts and so on from an AI perspective. But today we'll not spend too much time on that. Today, the main focus that I'm going to be talking around is around the anywhere concepts, the confident delivery, and the progressive delivery aspects. As we all know, a lot of this, especially in the CI/CD world, getting into GitOps, platform engineering, does take a lot of the right foundations to get it there in the first place. So even if starting with small companies right the way to large enterprises, we do have to put the effort in to get those foundations right and make sure that we do build out. And that always gives us a good starting point. It's always very difficult to try and re-engineer this back into workloads and pipelines that we may have already running. So it's always a good idea to really get those foundations in place, no matter the size. So as I say, the areas that I want to talk about are around the continuous deployment and Kubernetes, really focusing to deliver on speed, reliability, and security from that perspective. So what are the key areas? Obviously, implementation of GitOps. I think everybody in the room has been going through that for quite a while, starting in that process. It may start relatively simply, just with some actions coming out of Git or any other areas, but there are good drivers for why we continue to implement GitOps approaches and make sure that we have those practices in place. And a lot of that, as I say, is knowledge that you probably already have and why you're starting to put those GitOps in place. So it's a lot of areas that I'm sure you've taken and started to look at and probably are very well versed on the whole GitOps, but there's still challenges with it. When it comes to it, there's still, for those that are only starting to look at GitOps, was doing some research. I think a lot of teams and individuals who are involved in this sphere of Kubernetes, cloud native, whatever you want to call it. They already are very well versed in the GitOps, but there's still quite a larger section of the industry that are only starting to take a look at this. So that process of implementing and to look at that of how we support that with CAEPE through aspects of confident delivery. We talk about confident delivery, and the main idea of this is really, can you ensure that the delivery you're going to make for the best will in the world is going to be successful? What can you do before you actually hit the go button to ensure that everything's going to work? And CAEPE can support you in some of those areas as one example. So implementing pre-flight checks. So having pre-flight checks before you actually deploy, simply looking at a cluster, have the requisite workloads or resources in place to actually run any of my workloads. Dry runs in cases of larger teams where it may be one team who are working on the manifests and it may be another team who are actually doing the deployments. They may not know exactly what has been run in the manifest. So being able to run a dry run, make sure, okay, that's what they've changed. They haven't opened up any other endpoints. They haven't asked for any other deployments. So having a look to see what your manifest, what your deployment is actually going to do before you actually deploy it from that perspective. And then also post-deployment. What are you going to do post-deployment once it's been successful? Are there any actions that you need to take post that deployment? That might be running any chaos testing, any load testing, any smoke testing that you may want. To give you an idea of how CAEPE can support you on that side, from a deployment, we can actually just do the dry run directly or the pre-flight test. And as I say, pre-flight test can just look to see, okay, will this cluster actually have required resources? Like Nginx may require certain Postgres. And so just making sure that it's there before you actually run and do your deployment. As I say, it might actually be the dry run. So actually being able to execute dry runs in server modes to look at your manifest for your deployment, just to make sure that everything's good.
Merge anything to that stuff? Oh, it's gone.
The second area where CAEPE can support specifically that we want to look at is around the progressive delivery topic. So progressive delivery has obviously been coming up more and more, whether it's from a product management need of doing A/B testing, or as Wayne was talking about, being able to do canary deployments and making sure that you are testing small areas before you actually do full-blown deployments. We've seen what happened last Friday when you do an actual rollout right across the board. Might have helped to do a level of canary deployment on that side.
Our deployment pipeline, we had the option
so
that
how the practices that are involved in that, there are a lot of challenges
we can actually
involving progressive delivery when you're doing various
deploy,
types of deployments depending on your needs. And again, I can CAEPE support you in that area. So instead of having to sit down and implement it from an engineering perspective, being able to support and automate all of those processes, whether it's standard deployments, going to A/B deployments, blue, green, canary, right the way across. So that ability to actually simplify those processes and those deployments, so you don't have to sit down and look at your pipelines and actions, but actually just use CAEPE to configure all of that for you. With an example of an A/B deployment, we all know that from time to time we may want to push two different versions of the app just to get user feedback. So very simple with A/B deployments, we can push to different clusters, different cluster groups. We can push to actually see different namespaces within the same cluster.
If you see that
so depending on how you want to do those A/B splits, and then push out from there. So it might be the case that you're pushing to different regions in the world, different versions. It might be the case that you're pushing to on-premise. version versus the version that you're pushing out to the cloud. The third area to talk about is around the multi-cloud and hybrid strategies. So with CAEPE, one of the tenets that we look at is that ability to deploy anywhere. So if there is a need to support running on AWS, running on Azure, plus support what you're running in on-premise, it might be running an OpenShift on-premise, or even starting to push out into edge clusters, utilizing the likes of K3s and so on. So how can you set up tooling that you want in place to make sure that you have a single tool that's doing all of that for you and to support that and to support you with those challenges. So with CAEPE, again, we can set up various types. For us, we're agnostic to the Kubernetes, whether it's managed service or own managed, doesn't really matter. We're agnostic to what's running there. We're able to build down, push our deployments as needed, targeted to either types of those clusters or targeted to groups of clusters if they're all your on-premise clusters and so on. But do it all through a single pane and a single tool to make sure that your team are building out and utilizing one tool to do all of your deployments across that. With that, so very, very short in regards to an idea of how CAEPE can support you with some of the essential key components of the best practices that are out there, especially from a Kubernetes perspective, of what you need to do, where CAEPE can really support in extending your GitOps, the use of infrastructure, being able to deploy. We're not a Kubernetes management tool, but there's always needs to build clusters very quickly that you might want to smoke test if it's a new version, so we can support you in those areas as well. But mainly building out that whole idea of progressive delivery, the multi-cloud, being able to deploy anywhere, and also whichever mode, whether it's a push or a pull releases that you're looking at from your CD. But from us, it's really about extending what you're already doing in your GitOps practices and really pushing that forward. There is a few articles there written about those best practices when it comes to CD and Kubernetes, which you can reach out to. We also, for your own use, I haven't done a demo this evening. It's a short time space, but there's a full test drive to allow you to play around with CAEPE. So please, if you wish, go ahead to the website and try the test drive. It's fully supported with clusters and applications for you to deploy, play around with. You won't need to connect anything of yourself in. But if you do, obviously would like to thank you with that and give some swag with anybody who does take the opportunity to test drive from CAEPE. There's a lot more resources that we do have on the website, a lot more detail, breakdown of CAEPE through virtual demos and so on. So please go ahead and have a look. And if anybody would like to reach out, ask any questions, get more details, go through it, please. That's my LinkedIn, so please do reach out. I'd love to connect with you all. So thank you. Hopefully that's remembered there. Thank you.
Yep. Okay, cool. Okay, so I'm Dinesh. I'm from WSO2. So we are going to discuss something that you already know. Yeah. So this is what we are going to talk about today. History of exposing pods how you are exposing your Kubernetes applications to the world. And then the limitations of current practices. Yep, sorry. Is it not? Okay, sorry about that. So his history of exposing pods, and then limitations of the current ingress based options. And then we are going to talk about a little bit about the new gateway API, then what is API management, and the WSO2 APK. So these are the ones that we are going to discuss. History. Now, all of you already know how we are exposing our applications to the world, right? So we have our pods, and then we create services, then we use ingress and the ingress controls, and we expose our applications to the world, right? So this is what we are doing right now. And so these are some of the service options we have. And when it comes to ingress, we have Nginx and HA proxy, likewise, different implementations, right? So these are the some limitations of ingress controllers or ingress model. It is limited to HTTP or HTTPS, right? So the protocol level, there are some limitations. Then we have very basic routing options, right? So yes, based on the implementation, there will be some advanced routing options, but it is not available in all the ingress controllers, right? And then when it comes to security, still there are very few, basic features available, right? And also some of these features specific to vendor. When you are switching the vendor, you will have to change your Kubernetes artifacts, right? So these are some of the problems that we have with the ingress. So these are some of the examples. Now here you can see Nginx has their own annotations, right? So if you want to enable some features, you have to use their annotations, right? So here, this is from OpenShift. OpenShift has this capability. They are using route, right? And they have this weighted round robin options. And sticky section, likewise. And when it comes to AWS, they have their own implementation, right? So when you are switching from AWS to Azure, you will have to do something, some changes, right? So these are some of the problems that we have with the ingress. Because of these problems, Kubernetes, or the users of the Kubernetes, came up with this idea and then introduced the Gateway API. So Gateway API is a community-driven project. So it is trying to address the limitations of the ingress controllers. And it is started in 2019, and then they released the this CRD-based approach, right? So it is not part of the Kubernetes, right? It is not part of the Kubernetes. It is a separate CRD, right? Custom resources, set of custom resources. So you have to install those, and then you have to use it, right? So the Gateway API introduce the set of custom resources. So the idea is they let you do the networking, basically the routing, in an expressive or extensible and role-oriented model, right? So let's discuss or let's see how these different aspects, how it works. Now, in the Gateway API, they mainly introduce a new set of custom resources: gateway class, gateway, and route, right? Now, this is just a diagram explaining what these components are. So quickly, explain this. Now, in an organization, there could be a team who whitelists the applications that you can use within the organization, right? Now, some organizations might choose Java and .NET, only those languages you can use, right, within the organization. And when it comes to a project within that organization, they choose, okay, I'm going to use Java for this project, right? So this whitelisting part is done by the platform provider. They choose what are the gateways, what are the applications that you can use within this cluster or this organization. Then platform admin, he is the one who will choose what gateway to use for this specific project, right? And then the developers, right? So the developers will choose, basically they will be doing the actual configuration. What are the routes, things like that, right? How the traffic comes into the, what are the application related information, developers will know, right? So that is the idea. So now it is distributed. Now, earlier someone has to create the ingress controller, and then developers should know what is the ingress controller is. Based on that, they have to do the ingress related, Kubernetes artifact creation. Here, developers doesn't have to worry about anything. They just have to follow the same structure. And in any infrastructure, if the gateway class and the gateway is there, when you deploy your application, it will automatically connect to the relevant gateway, and then it will work, right? So developer doesn't have to worry about the underlying infrastructure. So these are some of the features that you have or you will get with the Gateway API. In addition to the ingress related features, you will get header-based routing, and then header manipulation, weighted trafficking, likewise different features. And also, you can do some extensions. You can implement your own routing and related implementation, right? So this is the Gateway API. So this is not part of the Kubernetes. This is a additional thing that you can install and use, right? There are different implementations. So again, one more thing, it is not a replacement for API server. You know what is the API server is. In Kubernetes, there is a component called API server, which will do the commands, within the Kubernetes control plane, there's a API server. And then the ingress controller is there. Gateway API is not a replacement, right? So you can use alongside these components, the Gateway API you can use. So Gateway API implementations, there are a lot of implementations, and you can choose whatever the implementation you have. I mean, you can use many in the one implementation, one setup. Now, WSO2 APK is one of the implementations. This is what we are going to use today to see how this works, right? Now we are going to switch the topic. This is API management, right? So now we are going to talk about API management. Now, in now modern days, like applications, mostly we are based on APIs, right? We expose our application through APIs, and we use third-party API management tools to do this, right? For the API management purposes. The advantages are basically you don't have to worry about the common functionalities like security, user management, throttling, and then analytics, logging, those kind of things. You don't have to write into your microservices, right? You don't have to worry about it. From central location, you can apply all these features, right? That is the idea. So now this Gateway API also works as a single entry point. So we can apply these API management features at this point, right? So that is the idea behind this WSO2 APK. APK stands for API Platform for Kubernetes, right? So it is providing API management features on top of Gateway API, and it is 100% open source, and it is based on Envoy Gateway project, right? So we introduce some new set of custom resources on top of Gateway API custom resources. And it provides full API management lifecycle support. And it adds security, monetization, subscription management, observability monitoring, these features, right? So these are normal API management concepts. Now, this is the diagram which explains how the Gateway API components and the APK components connected, right? Now, these gray components are the Gateway API CRDs, and the dark gray boxes represent the APK components, even the light gray ones are introduced by the WSO2. Those are related to the policies, right? Now, when it comes to normal application, when you are exposing it to the outside, the gateway, HTTP route, and the service will be used if you are using pure gateway API, right? So your application sits behind the service. The service will be connected by the HTTP route, and then gateway will be connected to the route, right? So this is how it works. Now, in addition to that, we have these separate other new components, which will add some new functionalities, like for each backend, you can have versioning, right? So there are some other features that you need, right, when it comes to API management. Those information will be kept inside these custom resources, right? In the backend, if you are backend using mutual SSL or some security protocols, then those are resides in this backend details, right? Because these gateway API haven't considered those concepts or those requirements. Later, we assume they will, combine these things and they improve the gateway API later. At that point, we can combine these features and then you can use it, right? So, but in the APK, we already provided these features. Now, let's have a quick look at the gateway API. Now, there is this online demo which you can use to try out the APK. It is available in the Kila core. So I will share the link later. So in this environment, we have created this demo setup. So as I mentioned earlier, all these are custom resources, right? So you will have to install these custom resources on top of your Kubernetes cluster. Then you can utilize these features, right? So first of all, we have to install the Helm, because the APK we are going to install using Helm. So this is an optional step I'm going to skip. Now I'm adding the Helm repo, and I'm applying the Helm install, and I'm providing some values specific to this environment so that it will set up the APK according to this environment, right? So with get pods, we will be able to see what this APK is setting up. Now, in the meantime, let me, while it is installing the Helm, let me show you the API gateway related artifacts, right? So here we can see I hope you can see the text clearly. Yeah. A second. Yeah. So we introduced a new artifact called API. It contains the name and the base path, this kind of information. And as part of the gateway API specification, we have HTTP routes, and you can have gRPC, likewise different routes, right? And then we have the backend, right? So these are the custom CRDs we have. Yeah. Now we have the APK configured in our cluster. So still some containers are getting created. In the meantime, I will set up my backend service. I have this microservice, Spring Boot microservice. Yeah. So all my services are now up and running. I have installed the APK, so it automatically deploys the gateway API, and also I have my backend microservice. Now, for this specific environment, we are going to add our host entries. And then I'm going to do a internal port forwarding just to try out these services. Now I have the backends, and now I am going to create or apply our API gateway specific artifacts with this command. So we already saw the artifacts, right? Now it created APIs. Now here you can see get APIs. This will give you the Spring Boot API, right? Now, normally you don't need the access token or anything to invoke a service exposing the Kubernetes, right? Now, in this case, we applied the security, so you need an access token. So with this command, you can generate access token, and then with that access token, you can access your exposed service. So the idea is, now without having an external API management platform or tool, you can use this APK and then do the API management within the Kubernetes platform itself, right? So let me, this is the final step. Yeah, so here you can see the hello world message from the backend. Now, if I do some changes to the access token, it is giving me invalid credentials like byte. So this is going through our APK component, right? So like this, you can apply API management features on top of the gateway API, and you can make your life easy, right? So that's the quick demo, and we can, if you have any questions, we can have it later, since we don't have much time. So this is the link for the documentation and the demo link, right? So you can try it out, right? Thank you very much. Yeah.
All right, Arvind, over to you.
Okay, thank you, Ritesh. Good evening, everyone. People in the back, am I audible? Okay, awesome. Thank you so much. Wonderful. Okay, I've been told 10 minutes strictly. Okay, so I'll try to be under 10 minutes. Okay. Again, first of all, thank you all for taking the time in your day to spend with another Kubernetes birthday celebration. Hope the cake was delicious. So my name is Arvind Kurapati. I don't know what my parents were thinking when they named me. It's a mouthful. You can call me AK. I respond well to that. And I head a channels business for Catalogic software. Okay? Now, quick agenda, just a quick introduction about who we are. And we will talk about a very, very specific challenge with Kubernetes and how we address that today. And we'll have some closing thoughts, and I do have a pop-up banner outside, a handful of coffee bean tea leaf vouchers to give away if you want to discuss more about this, if this topic is relevant to you. Okay, so who is Catalogic software, right? If you are if you're a regular attendee of CNCF events, you might have heard of Cloud Casa. You know, it's a third logo on top. We've been quite regular in sponsorship there, and our developers are also very active in the online forums for Velero and a few other things. So Catalogic is the parent company of Cloud Casa. Okay. So the company itself is 25 plus years old, and we are in what you call the data protection space. Okay. Everybody used to call it backup when I was growing up, but obviously now it's data protection because it's backup plus, you know, cyber resiliency and all those things. Okay? So we actually have 3 product lines. We're just going to focus mainly on Cloud Casa today and a little bit about B+, but it's a cross-platform data protection solution that's meant for operating systems, applications, virtualization, cloud, virtual machines, et cetera, okay? So it's a pretty broad offering of what we have. And I'm just going to leave this here just for a second, just to give you an idea of all the different kind of technologies that we cover. But we're going to focus just on this right-hand corner here on Kubernetes and the various managed Kubernetes services with which we operate well, okay? Now, like I said, we're going to focus today more on Cloud Casa, but we actually have two offerings for container data protection. One is V+, the other one is Cloud Casa, okay? You may want to pay attention to this slide because there may be a quiz question on this later on, okay? So, okay? So V+ is more IT operations oriented, whereas Cloud Casa is more DevOps oriented. The Cloud Casa is also backup as a service. V+ is your self-managed application. And we support, for example, OpenShift, containers, and KubeVirt, et cetera, along with a whole bunch of other virtualization platforms like VMware and Nutanix and Scale Computing, Proxmox, et cetera. So we support a long list. Okay? Whereas Cloud Casa, again, multi-cloud and cloud agnostic. We support AKS, EKS, GKE, OpenShift, SUSE Rancher, et cetera, et cetera. Okay? Now, the reason the topic today is application mobility, right? And we are taking a very, very specific use case, which is stateful applications. Okay? The challenges, again, I think there are different camps here. Kubernetes stateful, seriously, right? And people are like, no, it should be stateful. That's the way to go, right? So we'll not resolve that debate here today. But if you do go down the path of stateful workloads with Kubernetes, there are some challenges. Okay? Again, in the interest of time, I'm going to skip this through, but the traditional data protection approaches don't work in the Kubernetes world. Hence, there is something purpose-built Cloud Casa for that use case. Okay? So what I'll do is I'll kind of walk you through how, let's say, in this example, I'm going to walk you through, you have a particular workload, container workload on EKS, okay? And you want to move that to another EKS cluster, but not the entire cluster, right? Part of the workloads. And then along the way, you want to make some transformations to the cluster definition and the data, okay? So that's what I'm going to walk you through, okay? But the solution itself can work from any managed Kubernetes service to another managed Kubernetes service, okay? So in this example, in the screenshots that I'm about to show, it's specifically from Amazon to Amazon. I thought I'll do the host building a little bit of favor and bias my example on Amazon, okay? But we are completely agnostic, okay? Oops, what happened to the animations? Gosh, all my animations disappeared. Okay. I think I deleted. Okay. All right, guys, sorry about that. I should have done a quality check on this, okay? But I can go back to another PowerPoint where the animations were there, but I think we'll risk going over the 10-minute mark, okay? But we'll use the power of imagination, okay? So effectively, the steps here are, it's a backup as a service, right? It's a SaaS application. The first step is you add your AWS account. We'll discover all the clusters and cluster definitions and all of that. And then you would create a backup job where you pick a particular cluster, and then you can say, hey, back up this entire cluster, or we will help you browse through the resource types and namespaces, right? If you're providing, say, a service and each namespace could be maybe a different customer, right? So you may want to do some different backup policies for different namespaces, et cetera. So we'll help you define a backup job where you have some granular control on what you back up, okay? And then once that's done, specifically for AWS, we also back up things like the networking, right? Your VPCs, your load balancer information, right? So it's not just the Kubernetes only information, but also the AWS specific information, okay? So what you'll see is that you'll see a report that will show, hey, I successfully backed up all these components of your Kubernetes definition, okay? So that's step number 3, okay? And step number 4 is once you have a backup, a point-in-time copy, then you can do a restore of that, okay? Again, the restore doesn't have to be a like-for-like restore, and it doesn't have to be a full restore of the entire cluster, okay? So when you're doing the restoration, again, you can say, copy over the VPC definition, so copy over the networking information, copy over, the load balancer information, or you can overwrite, or you can also say copy over just these namespaces, just these resource types, and just these persistent volumes, right? So the whole idea is you have a point in time application consistent copy of your Kubernetes application, and then you are moving it from one place to another, okay? And so you define the restore job on what you want to restore. And the other thing that's pretty cool is you don't even have to have a destination cluster ready, okay? We can create the cluster on the fly and move the stuff to the destination cluster, okay? Now, so we will do all this. This is all UI driven. And once it's done, you can also drive it through APIs. It's not a problem, okay? So everything that you see in the interface essentially has an API interface as well. So it can all be API driven. Now, after doing all of that, you think that, look, I just want to overwrite something. I'm missing YAML, okay? We'll still give you the YAML file, okay? So you can do something in the YAML and then click the button to do the restore, okay? So you have the flexibility of using the interface and doing a multi-cluster data protection. And then again, you can view all the results, which is what you're seeing in the final screen, where what has been backed up, how much data was backed up, how long did it take, do you copy over the VPCs, did you copy over the load balancer information, et cetera, okay? So again, my apologies for not being diligent in the final copy here. So that's the example I had. But what we just did essentially is that, okay? You have a source cluster, you have a destination cluster, and we copied over everything essential, plus some service-specific information like the VPCs that I mentioned, and the load balancer information that I mentioned. And it can be used from any source to any destination, okay? So it can be GKE to AWS, or OpenShift to AWS, or OpenShift anywhere. Can be anything, okay? So really, it's pretty flexible, okay? That's one of the reasons why many of the cloud services partners use this as a migration tool. If you just want to migrate an entire virtual machine, I think all the cloud providers give you the tools to do that, okay? Whereas when it comes to the containers, the migration is a bit more challenging and nuanced, okay? So this also, so effectively, when I said application mobility in the topic, migration within the console, within the UI is a first-class feature, which is combining the backup and restore into a seamless experience, okay? So that's what we help you with, okay? So that's what Cloud Casa does. Hopefully it gave an idea of what is the data protection challenge and how we solve that, okay? Now, some of you may say, hang on, there is Velero, it's free. Why do I need to pay you guys for that, okay? So I would say in life, there are two kinds of free, okay? One is free as a puppy, one is free as a beer, okay? Free as beer, you get something free, you enjoy, have a laugh with your friends, and that's instant gratification. You go back home happy, nothing else to think about that night, what happened that night, okay? Free puppy, someone gave you a free puppy. You had to walk the dog 6 times a day. You had to potty train it, right? So it's a whole lot of overheads that comes with that free puppy, okay? So I would argue Velero is the free puppy, okay? Okay. So that's exactly why, everything that I said, the Cloud Casa agent, we have a proprietary agent, and it's zero touch agents that you can deploy in the cluster and manage a very large estate of Kubernetes clusters. Okay. Whereas Velero, it doesn't give you an operational dashboard or anything like that. So a multi-cluster management is very, very challenging. However, if you do have Velero agent, because that's how you started and your cluster grew, Cloud Casa can come and become the management layer for your Velero estate. Okay, so you don't have to change a thing. We'll start talking to all the Velero agents, and then we'll start giving you the same kind of functionality as well. Okay. So again, in the interest of time, I'll skip. So this is, I know we're all very technical here. You like to focus on technical stuff, but you don't want to get bogged down with things like, hey, interoperability requirements, compliance requirements, operational dashboard, management dashboard, all these things. And that's where we help, right? Now, when it comes to application mobility, I just talked about it, but then why do you want to do, under what circumstances would you want to do application mobility? Okay, so you may want to move specific namespaces, maybe a specific customer to a new cluster that you built. Okay, for OpenShift, for example, people use this to skip version upgrades because it's an incremental version upgrade. So if you want to go from version 5 to 10 in one go, this is the simplest and quickest way to do multiple version upgrades. Okay, OS migrations, Azure Ubuntu Linux to Azure Linux. Again, a lot of people are using for that kind of migration. Okay, prod to dev. Again, I have a wonderful case study of a large pharmaceutical company that uses for this. Yeah, and then if you use an interface and do step by step, you reduce the risk of human error. Okay, so concluding remarks, I would say you can meet your compliance, resiliency, and operational business requirements. Okay. With Catalogic software, with Cloud Casa and V+, so that you can chill. Okay, so exclusive promotion for people attending today. If you like what you saw and you think that your business can benefit from it, as long as you buy something before the end of 30th September, we'll be happy to give away an annual subscription of KodeKloud Pro. Mumshad, I hope you're happy to hear that. Okay. And I'll leave my contact details here if anyone wants to scan. I'm also available outside during the break. I have put up a pull-out banner there. And like I said, I have a few coffee bean vouchers to give away if you want to have a chat about how data protection and application mobility can help. So that's my time. Thank you so much. Sorry if I overran.
All right. Thank you, Arvind. Thank you for a wonderful session. And now we move on to our next speaker, which you guys are most waiting for, to learn from Daniele Polencic, the owner of Learn K8s. And as I said, everybody who is into Kubernetes have definitely heard about Learn K8s and have gone to this website and tutorials once in your lifetime. Over to you, Daniele. I think should be.
I know you're looking for swag, so 10 minutes. I know it's been said before, I'm going to stick to the 10 minutes, but to make it more challenging, is anyone going to start the timer now for me? You do it? Okay, let's start the timer. 10 minutes, okay? Okay, so I'm going to use these few seconds just to optimize my 10 minutes. So I'm going to switch through. I'm done. I work for a company called Learn Kubernetes. You might have seen some of the things we do. We generally help people learn Kubernetes. So we share interesting articles and jobs and events, everything related to Kubernetes. I think those are the two most important slides you will see today. That's my name. People call me Daniele, Daniele, Dan, D5E. You can call me anything you want, that will work. That's how much I am into Kubernetes. I just shorten everything for a first letter, last letter, and numbers in between. I had the pleasure to speak at KubeCon twice. I was meant to speak at KubeCon Hong Kong, but things didn't plan as well. And what I do on my day-to-day job, I teach Kubernetes. That's what I do. I'm an instructor, and I basically just help companies get up to speed with Kubernetes. And the next workshop is in a few weeks, actually, here in Singapore. I'm running a workshop. And when I run this sort of workshop, there are some questions that pop up fairly often, right? And one of those questions is, okay, I've got a cluster, but what kind of instance should I use for my cluster, right? Should I use a small instance? What kind of EC2 instance should I go out and buy? Should I use a Graviton? Should I use a normal x86? And at the beginning, when I got that question, I was like, yeah, just pick any. Does it matter? Right? Kubernetes will make it work, right? But it turns out that things are way more complex than that. And I'm going to show you why. But before we do that, we need to understand how Kubernetes works, right? So if I look at Kubernetes, the way I think about Kubernetes, I've got a collection of servers. And what I do is one of these servers is going to run the control plane. And the rest of the fleet will basically be worker nodes. So basically, that's where we deploy our applications. But from a perspective of a user, right, what I see is a single cluster. It doesn't matter if I've got 100 or a single node. What I do is just deploy containers, right? As simple as that. But in reality, what we have is Kubernetes will basically look at these containers and find the right placement inside the infrastructure. And this is where things get interesting, right? Kubernetes doesn't really mind what's the size of this instance, right? As long as you can deploy a container, then you're fine. And Kubernetes will do basically just look at the memory and CPU and will just aggregate those values, right? And that's basically the overall CPU and memory you've got available in the cluster. So the question at this point is, okay, I've got a node and I've got some pods. And should I use a small instance? Should I use a big instance? Well, it turns out that things are a little bit complicated. So let's have a look at an example. I've got an instance, and this instance is an 8 GB of memory and 2 CPUs. And I've got a pod I want to deploy, and that pod has got 1.5 GB of memory and 1/4 of a CPU. So if I run the numbers, I can fit 4, right? So I try and deploy 3, and I scale to 4. What do you expect to happen? Right? I expect the 4th one to go on 4th slot. But if you actually run this, it will say pending. A new node will be provisioned, and that pod will be deployed in the new node. Why is that? Doesn't make any sense. Well, it turns out that in Kubernetes, you can deploy pods, you can deploy workloads, but there is some memory and CPU which is reserved for the operating system. There is some memory and CPU reserved for the kubelet, and then there is some memory reserved to what we call the eviction threshold, right? So all of those basically are things that you cannot use. If you subtract those from the node instance, then you get the memory and CPU, which you can use for your workloads. So how do I select the right instance? So generally, this is what I do. I pick an instance, and then I count the max number of nodes I can fit, max number of pods I can fit in that instance. And then I divide that by the total memory available. And that gives me like a block, a unit of block, and saying, okay, I can fit, 110 blocks, which are 257 megabytes of memory, right? Then I repeat the same for the CPU. And then what I do, I look at my application and say, okay, how many blocks do I need to deploy this application, right? In this particular case, the blocks that I need are 24. And then I try to fit inside, and I check how many could fit, right? And then I go back and I basically do the same thing, but with a bigger instance, right? Different memory, different CPU. I compute the units again. I compute the CPU memory units, and then I try to fit again the same application. This time the units are bigger, so I can fit more, and there is less space underutilized. Now, it turns out that doing this kind of calculation, I was doing these calculations in Excel, and it was terrible, but it worked. It worked. And then finally, we basically put together a small calculator to actually try those interactively. And this is basically what I want you to show you today. So I don't know why my screen is so dark. But let's have a look at, I want to deploy a 6 GB of memory, half a CPU workload. 5 minutes. What should I do? What kind of instance should I use? Let's have a look. So this is the calculator. I'm going to zoom in a bit. And this calculator is divided in 4 blocks. The first block is I input the request and limits. And there is a block for the cloud provider where I can drill down on a different type of instances. And there is a list of instances I can consider. And then for each instance that I select, there's going to give me some extra information about that particular instance. So let's have a look at 6 GB of requests, half a CPU. I'm going to go for AWS. I'm going to order the list from based on the cost for the pods. And what is this telling me? It's telling me that the best instance I should use for my workload is an R6A 32x large that can fit 250 pods, but I can only effectively, if I have these requests, then I can only fit 178. It's telling me that the pod will cost on average $1, close to $1. And this is what the total allocation will look like, right? And what I can do at this point, maybe it's small. Let's have a look at this. I can do, I can compare this, right? I can compare with different instances and see what kind of things change. For example, if I select the R6A 4x large, I can see that, I go up 1 cent per pod, but I can actually fit less. Is this good or bad? Well, it depends, right? Usually ask myself the questions, what if I were to lose an entire node? How many pods would be affected? So I can basically compare the 2 different scenarios I've got. And then lastly, I can also compare different cloud providers. Is AWS really better? Can I go in Azure? What do I get? It sounds like I can use an A64 AS P5. This is going to give me some sort of similar value, but at the same time, I can see that I'm probably overestimating on CPU. Okay, back to the deck. So what did I learn in this experience building the calculator and just studying this space of how do I choose select an instance? So generally in Kubernetes, bigger is better. So bigger instances will give you better utilization. Azure has got a very low max disk. So if you're running stateful workload on Azure, yeah, you need to watch out for how many disks can be attached on the instance. There is something in AWS called prefix delegation, which gives you the ability to run more pods inside instances. I think that's probably overrated. I noticed that it actually harms more than helps. And the other thing which I noticed is that it's extremely hard to figure out requests and limits. Because requests, you try to model requests as actual usage of the application, but the actual usage goes up and down. You change code, it goes up. You change something else, it goes down. More requests goes up, right? So that's extremely tricky. And the other things which is related is that if you change requests, then everything will, those changes will trickle down everywhere. Because we use requests for quality of service, and they are used for scheduling as well. So getting it right, usually quite tricky. 10 minutes. I've got 1 minute left. 1 minute left. See? So thank you very much for joining. So I am this guy. These are some of the accounts that we generally use to publish our news. And I also, regularly publish a newsletter if you are into it. Yeah, that's it.
Thank you, Daniel. Thank you very much for insightful session. Now we are almost at the end of our today's evening. Before we go forward with the quiz and the session, I would like to invite Mumshad, who would like to talk about would like to come and share with you.
This is on?
Yep.
Yeah, hi guys. First of all, thank you for coming here. My name is Mumshad. For those of you who don't know, I run a training platform called KodeKloud where we teach Kubernetes. And Daniel here mentioned, I'm also a teacher. We both are kind of teachers. But then you must be thinking, who's the better teacher? Yeah. So it took 10 minutes. And I'm only going to take 1 minute out of that. You want to start timer? Yes, so yeah, I'm not going to teach anything. Just here to say both thanks to everyone for coming here and making it to this space, and also the organizers for organizing this event. I just want to leave you all with something exciting that we're working on at KodeKloud in terms of tech education. So we have a small 2-minute demo that I'll play, and well, I guess I'll just leave you all with that, and you can look forward to seeing it on the KodeKloud platform in the coming weeks. Right?
Let us first inspect the environment. How many containers are running on this host? Hi, how do I do this question?
To find out how many containers are running on this host, we can use the docker ps command. This command lists all the running containers. We can then use the wc command to count the number of containers. Let's look at the full command, docker psq wc-l. This will output the total number of running containers on this host. Go ahead and try this command and let me know what you find.
The answer is 1. Us first inspect the environment. How many containers are running on this host? Hi, how do I do this question?
To find out how many containers are running on this host, we can use the docker ps command. This command lists all the running containers. We can then use the wc command to count the number of containers. Let's look at the full command, docker psq wc-l. This will output the total number of running containers on this host. Go ahead and try this command and let me know what you find.
The answer is 1.
Great. The correct answer is indeed 1. Let's move on to the next question.
Do this question.
All right, let's take a look at how we can run an instance of the KodeKloud Simple Web App container with the blue tag and map the container's port 88DU to port 38282 on the host machine. To do this, we'll use the docker run command. We'll specify the -d flag to run the container in detached mode, the -p flag to map the ports, and then the image name and tag. Go ahead and give this a try.
Can you do it yourself?
The container has been successfully started. You can verify it by running the docker ps command.
Thanks.
You're very welcome. If you have any more questions or need further assistance, feel free to ask. We're here to help. Happy learning and experimenting with the lab exercises.
KodeKloud.ai. Nice. So now we will move on to our last event of today is quiz competition. And before we move on to it, before that, I would request you all to scan the QR code and give your feedback for the event that has happened today. Your feedback is valuable to us. All right, please scan the QR code and join to the quiz. And yeah, there would be 10 questions. 10, right? Was it 10 questions? 10 questions, 4 options, 1 right. You will have a time. 6 options. Okay, 6 options. 1 of them is correct. There will be a timer of 20 seconds. And so first 3 winner will get KodeKloud subscription Pro for 6 months. And we have some t-shirt swag from CAEPE and WSO2. So we would be giving out those swags as well to the winners. So the online attendees can also join, and if the winner is from online, we will give you also, if you're one of the winner in top 3, you can also get KodeKloud subscription. So please join using the QR code.
Anybody have issue? I'll join them.
Is the screen visible? It's enough? Means, do I need to zoom in or it's okay? Fine. So I'll hand over to Anuj, my colleague. He would take over. Question.
I will just read out the questions for your ease. Starting it now.
On your screen, mobile screen.
Which of these AWS instances types as Graviton 3?
Finish.
Next question. Which of the processors below make use of hyperthreading? Next question. Which of the following tools make use of QEMU emulator? I hope Docker is right. Next question. Which of the following CI tools does not have hosted ARM runners? Next question. K8s Gateway API is dash. Okay. Next question.
characteristics of WSO2 APK. Next question. Which of the following is not a challenge associated with GitOps? Next question. What does CAEPE pre-flight feature ensures? Next one. What is the purpose of a dry run in the CAEPE's deployment process? Okay, the last question. What is the primary challenge when adopting multi-cloud and hybrid cloud strategies? Okay, the hard part is over. The last time I was also but not mind.
So awesome. We had 63 participants, and out of them, I would like to call Rizwan, Norman, and Dulanjana on stage. The top three. Anybody from online who has won? Can you check the chat? Norman, Dulanjana, okay, and Rizwan. I think he's online. Is Rizwan online? Okay. So, Rizwan is online. First three ko dena. All right. So Rizwan, please share your email address on the chat. Okay.
Yeah, sure.
Yeah. Please take a photo. Take a photo. Mumshad.
Yeah, I already shared on. Thank you.
There is one.
Shared in the group chat.
Okay, great. You will receive an email. Okay.
Cool. Thanks.
All right. I would like to call Somansh, Raghavan, and Robin, and Hafiz. Somansh, Raghavan, Somansh.
Robin? Hafiz? Okay. Augie? Augie? So first three will get the KodeKloud subscription. Remaining guys will get t-shirts from our sponsors. So first we take a photo. Everybody just line up. We take a photo of the winners. Yeah, you guys come. Remember, you guys are winners. First we'll take a group photo. Everybody please join us on the podium for a group photo. Then we will start.